Okay, good day and welcome again for the third part of the CCNA 20301 exam preparation series. For April, right now, for April 2020, it will be only 4 parts covering almost 100 questions. And whenever there will be some updates in the future regarding some new questions that you might also face, some rumors, or maybe any of my friends that might advise with some questions, then I will also add them at their time. So whenever you are taking the exam, maybe you'll take it this year in April, then only the 4 parts should be enough for you. Of course, after you finish the complete course of this exam, being fully prepared, uh, do a lot of lab testing, practicing, etc. And that should be enough for you. But if you want to take it like in May, June, July, or furthermore, then it would be better to check the playlist of the exam preparation for the CCNA, of course, for the English series CCNA exam preparation, and see if that there might be some new videos that were uploaded in those months of May, June, July, and so on. So that would be an update that you might probably need. Okay, so without further talking, let's start with today's part 3, and that says, starting with question number 51. Okay, that should be, refer to the exhibit. If OSPF is running on this network between two routers, each router is giving to a certain site with, of course, some private IP addresses from these sites, but together they are connected using two links. How does router R2 handles traffic from site B to 10.10.13.128/25 at site A? So if someone wanted to reach 10.10.13.128/25 network, which lies here, but that someone wanted to reach that network through router RB, then according to router 2, then according to router 2 routing table, then we should know using which protocol or path. So like we have right now currently, surely it will not be the C, because we are talking about something in site A, it's not a point-to-point, so definitely will be O. So there it is, 10.10.13.0/25. Okay, so it's 10.10.13.0, 10.13.0/25. /25 gives you only 128 valid IP addresses. So since the ID is 0, so it starts from 0 up to 127, which is the broadcast domain. So this one is a completely different and isolated network than this one. Okay, so it's not even mentioned or routed here, neither on using the routing table. So neither on Fast Ethernet 01 or 02, it will not work or operate. It will not work. It will not route. This router has no idea that by using OSPF, how can he reach this subnet? He knows how to reach this one, which is almost like the first half of a big network of 10.10.13.0, but the other half, which is 10.10.13.128, this one is not advertised in R2, so it should not reach it. So it sends packet out of Fast Ethernet 01, neither 1 nor 0, no. It load balances between the both of them, just in case it was advertised, then it will, but it's not advertised, as you can see, so it cannot send the packets to 10.10.13.128, okay, because it's not mentioned at all. Okay, so it will be answer D. Question 52. Which two outcomes are predictable behaviors for HSRP? HSRP is the first protocol that we spoke about back in chapter 4, which was one of 3 brothers. All of them belongs to the FHRP, First Hop Redundancy Protocol. So HSRP, which is the Hot Standby Redundancy Protocol, it was only about interpreting and discussion about that protocol in chapter 4 of this CCNA series. In the CCNP Enterprise, there will be further discussion and implementation about it. I'm also planning to add HSRP in the Mega Lab series that I will make for the English course, because mostly a CCNA engineer would need to know how will that work. Okay, it will not be about a lot of details, because a lot of details for the HSRP will happen in the CCNP Enterprise course. But for the right now for the CCNA only, it will be a brief lab regarding the HSRP. Now it's better. So anyway, what are two outcomes predictable? Are predictable behaviors for HSRP? Choose two, and it's 5 answers, so I will choose two. A, the two routers negotiate one router as the active router and the other one as the standby router. I have talked about that. Yes, that is correct. It will be an active and standby state. The two routers share the same interface IP address, and default gateway traffic is load balanced between them. Definitely there will be no load balancing using HSRP, and also there will be no single IP address that will be used in two devices. This is definitely will be a duplicate, because these two routers will be connected together through a switch. So you can consider these links in the same broadcast domain, so you cannot give an IP address here and the same IP address here. It should be a different IP address, so these two routers will not share the same IP address. No, they will generate one virtual IP address that can be shared between them, and the thing that will be actually the HSRP or FHRP behavior will be like creating one virtual router between them that you cannot see, and that virtual router have a virtual IP address that no one uses or no, and this one will behave like the two routers combined or merged together. So this is the idea: creating a virtual MAC address, a virtual IP address, assign them to a virtual router. All of them do not exist really, but just to make both of the routers behave as the same router once a failure happens. So C, the two routers synchronize configuration to provide consistent back and forwarding. No, this have no idea, has no relation to HSRP. Each router has a different IP address. Okay, I agree. Both routers act as the default gateway on the LAN, and traffic is load balanced. No load balancing happens with FHRP at all. With HSRP, I'm sorry, because with GLBP, the third one, there is a load balance between them. So hopefully it will work. The two routers share a virtual IP address. Okay, so far we are good. That is used as a default gateway for the devices in the LAN. That's correct. So imagine that you use the IP address .1 in this router and the IP address .2 in this router. Both of the IP addresses will not be advertised or used as a gateways to the devices here, to the computers or even switches. What will be used as a gateway for them will be the .3, which is the virtual IP address of the virtual router that we cannot see. So the computers will try to communicate .3, but firstly they will think that .3 relies here inside this router, so I will go this way. Once this router fails, then they will keep searching for .3, and again they will find .3 also virtually relies inside this, or lives inside this second router, so they will jump to the second router and continue the working. This is the concept of redundancy by using the FHRP protocols. Okay, so my answers will be A and E for question 52. For question 53, okay, there is a topology with some serial cables and an IPv6. Refer to the exhibit, which is this one. An engineer is configuring the New York. Okay, this should be K, because this should be a new. Okay, there should be a K here. It's not okay, so it will be in New York because this is New York. Okay, so YORK. An engineer is configuring the New York router to reach the loopback interface, loopback 0 of the Atlanta router using serial 000. Okay, so loopback interface, just in case you have no idea about loopback interface. Okay, this is a router and this is a multi-layer switch. There will be a different thing, there will be a different naming here, but the same concept in the end. What happens is that all the routers, actually before the only routers, maybe routers, these routers you see, this is a router that has multiple interfaces. Each interface should be unshutted to be enabled, have an IP address, subnet mask, already have a MAC address, etc. And that's it. You can use it like a gateway, a default gateway, default route for the DHCP, a gateway for the LAN, etc. and so on. Another thing that you can use from the perspective of redundancy with routers only is that there is something called loop back interface, and these are unlimited number of interfaces that you can virtually create inside a router. Imagine that it's created inside the CPU of a router. Okay, so this is a port that relies here. So this interface can be reached by maybe using a cable and inserting the cable to this interface. This interface can be reached by like extending a cable and attaching the cable to this interface. Okay, how can we attach a cable, or how can we reach an interface that's in the heart of a router? Actually, this is a concept of redundancy, because this interface or its IP address can be reached through any up and enabled and working interface right now in the router. So maybe your router has 4 interfaces. Randomly, the traffic will go to the loopback address through one of those 4 interfaces. One of them is down. There are other 3 interfaces that can serve this loopback. Another one is down. There are 2 interfaces. The third one is also down. There is a last and fourth interfaces. So whenever there is an interface that is up and running in a router, the loopback address is up and running also, and you can reach the loopback address. So it's really important. Why I mentioned the multi-layer switch? Because in multi-layer switches you can create something called interface VLAN, and it has the same concept. It's a virtual interface that does not really exist, lives inside the heart of a multi-layer switch, and has an IP address. It's an interface VLAN, so yes, it's something hybrid because it's a gateway for VLANs, not for normal IP addresses or VLAN-less LANs, and there is no such thing as VLAN-less LANs actually, but just an idea. It's a gateway for VLANs. This is number one, and number two, you can reach it through any valid interface right now. Okay, so that should be good. So this is the same idea. So loopback 0 is like a virtual interface in the New York router, configuring the New York router to reach the loopback 0, sorry, of Atlanta. So this is Atlanta. In Atlanta, there is a virtual interface here that we do not know. Actually, we cannot see. I'm sorry, not do not know, and we need to read it. Oh, I'm sorry. We need to reach it. I'm really sorry for that. Okay, so an engineer is configuring the New York router, which is this one, to reach the loopback 0 of Atlanta router, which is this one, using serial 000 as the primary path. So this is serial 000 and serial 000. By the way, these are some serial cables that are really obsolete and old. Can ignore them. Cisco has removed them from the topics and blueprints of the new CCNA exam, so I did not discuss them. Actually, I have only discussed copper, and by copper I mean Ethernet, because these also are made of copper, but they carry like 1.5 megahertz. I'm sorry, megabits as a transfer speed, or megabytes as a bandwidth. But what I meant is that they have been removed from the new blueprint, so I did not mention them at all. So the idea right now is that New York wants to reach the this loopback of the Atlanta through this interface, this link that combines 000 and 000 serials, which 2 commands must be configured on the New York router so that it can reach the loopback interface of Atlanta, okay, via Washington router, which is this guy, when the link between New York and Atlanta goes down. So as I can see from this command, this is an IPv6 static route, and you know the static route supports no redundancy, not like dynamic routes. Dynamic routes do discover, do send hello messages, do exchange some LSAs or some other types of packets between them, do imagine and draw some topologies inside the router's brains so that they know their neighbors, neighbors, and so on, so they know the entire topology and can behave whenever an interface goes down. Then they will know another redundant path to go through to reach the same destination. This is for dynamic routing, routing protocols. For the static route, you will only mention like go from this way to this, go to this route to reach this destination, and that's it. You will leave it. So once something happens to this link, you're done. Okay, so this will be unreachable. This destination will be unreachable. It will go down. What you will need actually is for this question, is to set up or route an IPv6 static route, an IPv6 redundant static route actually, or a redundant IPv6 static route. Okay, we need to consider English here. Okay, so this redundant path, we must configure it inside the New York router. Okay, so let's see that there is some config that's already there which is these are some IPv6 addresses of the physical and logical interfaces for Atlanta, New York, Washington. The idea now, right now, is that we need to configure an IPv6 static route with a higher, by the way, you should have been watched the video of the floating static, because right now this question is about floating static route, because you need to configure a redundant static route that appears whenever the primary static route goes down. So we will configure a floating static route with a higher administrative distance than number 1, maybe 2, 3, 4, 5, 6, etc., maybe up to 10 or 19. Will not make it up to 20 because that's for IBGP. And this floating static route will be configured twice. First one from this route to Washington, from New York to Washington, and step 2 will be configured from Washington back to Atlanta. That's why it says choose 2, because we need to configure it on 2 steps. So step number 1, I need to configure an IPv6 static route with a higher ID than the 1. Okay, so you can see that this command is IPv6, this subnet goes to this destination, and after that it's silent, it's blank, there is no higher ID that's configured, so we can consider this is not a real option that we can use, because this is not a floating static route. C also is not a floating static route, so we have to choose 2 answers from B, D, and E. Both of them, 2 of them are correct, and the third is wrong. Okay, so step number 1, I need to check the IP address of serial 000 of this router and use it as my destination. Okay, so for reaching from New York to Washington, so serial 00 for Washington is, this is Washington, this is serial 00. It has the IP address of 2023:3/126. Okay, so this is my destination, and the route that I want to reach is the loopback here, the loopback of Atlanta. So this is Atlanta, and the loopback will be 2000 1/126. So I need such route that to reach this destination, go to this next hop and use an X amount of AD. So let's see of those here. All of them are using this is /126. Are you sure? It says /128. Okay, so Atlanta, I'm sorry, it's 128. I did it 20. Okay, so this one is 8. Good. Okay, so all of them are using the destination of loopback. I agree, no problem. All of them have a floating higher ID, no problem. But what we need is that this destination 2023:3. So this will be 2023 : this one 2023:3. So this is step number 1. I need to use that this IPv6 route, static route, to route the subnet from New York to Washington. Step number 1. Step number 2, to complete the route as a second step from Washington to the end, which is to Atlanta. It should be using the same destination, so it will be the same one. The only thing that should be changed is the next hop, which will be serial 001 of Atlanta, to throw the route from here to here, this way. Okay, so the only thing that I need to change for the command, I will use the same destination, only I will change here the next hop, which is serial 001 of Atlanta serial 001, and this has the IPv6 address of 2013:1/126. So of these 2 options, I will need 2013, not this one, 2013, neither this one. Okay, so now we have a big problem. Why? I will tell you why, because only 1 minute. Let me see if I need to configure that on another interface, because both of them, oh, okay, this one is definitely correct, but what I need is actually I need to mention the floating AD on the first router, but not on the second one. So these options might be useful. Just 1 minute. Let me unlock them, because they might be just useful. Okay, so let's see. Manager is configuring the New York router. Okay, an engineer is configuring the new router to reach the loopback 0. And the loopback 0 address is 2000::1. Okay, I agree. Of Atlanta using serial 00 as the primary path, which command must be configured on New York. Oh, I'm sorry. Both the commands should be configured in New York. I thought that it needed also in Washington. So we need two commands on New York. The first one is this one, okay, which I agree on, to sending the packet with the floating route. Okay, this one. I believe on Washington, the Washington engineers will do it. I live in New York. Okay, so I will do. I'll do only the New York router. Okay, so we need two commands that must be configured on the New York router so that it can reach the loopback address of Atlanta router via Washington when the link between the two. Okay, okay, I agree. So for the first one, this is for the redundant one, and the second one I believe should be the main route itself. Mhm, 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 mhm. The main route itself, because so far we have configured the redundant one with a higher ID. This is a floating setting, and I haven't even configured the main path, the primary path. And the primary path is routing the destination of 2001, 2000, I'm sorry, colon 1, which is this one, but through serial 00. So that will be by configuring the next hop of serial 000 of Atlanta IPv6 address, which is Atlanta serial 000 2012::1. Okay, so I will need a 2012::1. I have these two options. One of them will be considered as floating, the other one will be considered as primary. So I'll go with the primary one. Yeah. So these are two commands that should be configured inside New York router. One of them for the primary static route, which is answer number A, as answer A. The other one is for the floating static route, and this will be answer E. So I hope after all this mess you got the idea of question 53. Okay, let's jump into question number 54. How does HSRP provides first hop redundancy? It's because that I have already discussed that in question 52, I believe. But let's see the replies. A, it load balances. There is no load balance. There is no load balance. And okay, so there might be VLANs, but there is no load balancing in the FHRP or HSRP. I'm sorry, in HSRP. HSRP is considered as an active standby scenario, so it will not be a load balancing. It uses a shared virtual MAC address. I agree, and a virtual IP address, to group to a group of routers that serve as the default gateway for host online. This was the same reply of 2 questions ago. It was the same thing that I talked about. So yes, it's correct. And let's see if there is another correct thing. I know it's only one reply, but let's see. It forwards multiple packets to the same destination over different routed links on the data path. No, it does not do that. Definitely, there is no load balance. Whenever you see load balance, just delete it, unless you use a different scenario that's called multiple groups of standby groups, and I might do that in the Mega Lab series, or might not, because this is a CCNP topic right now. Okay, DND. A network engineer is configuring OSPF v2, which is IPv4 OSPF, neighbor adjacency. Drag and drop the parameters from the left onto the required categories on the right. Not all parameters are used. Why not all the parameters are used? Because we have 5 answers and 6 parameters. So one of them should be neglected. Okay, so this is mean neighbor adjacency. This means that I have 2 routers that are connected directly. What are the things that when I configure both the routers that should match to have a neighbor adjacency? What other things that must be unique, like different for each router, and also to establish adjacency. So area ID, definitely area ID should match, because if this link was on area 0 from here, then it definitely should be on area 0 from here. IP address should not match. Each interface should have a different IP address. This will be called duplicate IP address. Subnet mask should match, okay, because subnet masks should have both the interface under the same broadcast domain. So subnet mask should match. That should be here. OSPF process ID. OSPF process ID. I don't think so. I think that I have read an article once, or maybe one of the books that I have studied OSPF with, that says process ID should not really match. But if we just left it for a few moments and head to the router ID should be unique because it's an IP address. So just like the IP address, router ID should be unique, and timers should match. That is something that I'm sure of. The hello timer by default is 10 seconds, and you can change that. And there is something called the dead interval timer, which is mostly 4 times equal the hello timer. So by default it's 40 seconds. These things should match because these are how often do the router check each other, and they should match between the two links. So since I'm not sure of the process ID, we can neglect it because we have only 5 blanks to fill, and we can use the timer as a should match. And that's it for question 55. For question 56, R1, I don't see R1, but let's see. Okay, no problem. Has learned a route from this destination, or from this guy, from this source, via ISIS, intermediate system to intermediate system, OSPF, RIP, and an internal EIGRP. So under normal operating conditions, which routing protocol is installed in the routing table? You know the competition between routing tables, routing protocols, and which one the router should elect as its champion to deliver the mission. This depends on the AD, and the lower AD wins. Whenever you see an internal EIGRP wins. That's it, because it's the lowest one between all of the internal routes. Okay, only the external BGP has a lower AD than EIGRP, because the BGP, and actually it should be small e, has a 20 AD. IBGP, which is internal BGP, has 200, and the other guys like like EIGRP has 90, the lower one between the internals, so it will always win. OSPF has 110. ISIS, I believe, has 115, and RIP definitely will have 120. So this guy will never win. I'm sorry, because these brothers are here, and EIGRP will always win. So whenever there is an internal EIGRP, internal EIGRP will win. Okay, by default EIGRP is an internal protocol. External EIGRP is rarely used. Okay, so question 57 says that refer to this exhibit. The default information originate command is configured on R1. This is R1 or OSPF config. Okay, after testing, workstation on VLAN 20 workstations. Oh, where is VLAN 20? Okay, let me see. At site B. Okay, so this is site B. So there should be some workstations inside here. Consider them as the computers. Cannot reach the DNS server on the internet, which lies here. So it seems that those guys are reaching their router, and after configuring something here on R1 by using OSPF between these two guys, the packet is stopping here and it's unable to reach R1 and thus to the internet. So this is the config of R2, this is the config of R1. Let's see the difference. See, they make it something difficult, like this is show IP route for R1 and this is show IP route for R2. You can put it just as JSON to it so I can read them. But anyway, I can notice something here is that there are some OSPF routes for R1, not for R2. This is something, and there is another command says that show run router OSPF and show run router OSPF. So let's compare these two. Router OSPF1 matches between both of them. Router ID, each one is unique. Log adjacency changes, this does not really affect. Auto cost reference bandwidth 10,000, the same thing, this will not affect. R1 has the config of default information originate, but it has only one network. This is R1, and R1 is actually in the middle between two networks. It's only advertising one network, which is 10.10.10.2, which is this one, in area 0, but it's not advertising the internet. Okay, and that's why you can see that R2 did not receive any OSPF from R1, nothing in the routing table. So let's see the possibilities. Add the default information originate on command. No, this will not affect it. Add the always keyword to the default information originate. This one also will not do it. Configure the IP route 000000000. These two T and D are default route, static default route, which is something that you use to route everything for a destination. Everything that was not mentioned in a protocol, then routed to this destination, which is either this destination or this one. But let's see, this it says that configure a default route to the destination of 10.10.10.18 on R1. So this is R1, and 10.10.10.18 is this one. So if you configure the default route inside this R1, saying that whenever you receive something that you don't know where to route it to, then route it this way. That will definitely make the packet of site B goes ahead to the DNS. But D says that configure an IP route on R2 to 10.10.10.2, which is this one. Actually, there is no need, because R2 already advertises this network with R1. So R2 already knows how to reach R1 using OSPF, but R1 needs also to know how to reach the internet by using the static default route. So it will definitely be C for question 57. Question 58. Okay, Ben, working. Okay, question 58 says that refer to this exhibit, which metric was the route to 172.16.0.202. 172.16. Okay, so this is a static default route. These are the 172.16. We need to match the longest match. Dot 0. So far, all of these four are good. And then we have dot 0/16, which includes 65,000 IP address. Okay, so this one matches so far. Dot 0.0/24. This one also matches, because dot 0 and /24 means that there is inside it 254 IP address. So this guy is included. Also, this one works, but this one matches, has a longest match than this one. This means that this one is better. And 172.16.0.128/25 gives 128 IP address, and the ID is 128. So 172.16.0.128/25 means that this is the ID, and it ends in 128 IP address. After that, that will be 255. Yep. So this is the network ID and broadcast ID of this third line. So these guys here will also include the 202 between them, because this one lies between 128 and 255. So this one also matches, and it's even has a longer matching criteria. So okay, so this one is even better, because it's a smaller subnet, yet it still includes this IP address, this destination. So far these three guys, all of them matches, but the more specific the better for the route. The last one will be 172.16.0.192 /29. Means that there is a 30, 31, 32, 3 zeros, which is 1, 2, 4. I'm sorry, 3 zeros. So number 2 to the power of 3 gives us 8. So this subnet starts with the 192 and has 8 increment value. So this will end with 200. Let me type it, should be better. 172 dot 16 dot 0 dot 192. Since it has an /29, then there is a 30, 31, 32 until we reach the 32 bit. So 3 zeros. So 2 to the power of 3 gives us 8. So 8 is the total amount of IP addresses. 192 is the first one. 193 is the second one. 94, 95, 96, 97, 98, 99 is the eighth one. So this network ends with 160199, and this one does not include that, unfortunately. So I will go, and I'm sure of this guy, OSPF, using 172.16.0.128/25. So you need to know the metric, and the metric is, this is the AD and this is the metric, 38,443 exists. Good, good, good. Okay, so it will be C, definitely. Okay, let's head to question 59. Okay, question 59 says a user configured OSPF in a single area between two routers. Okay, so I have two routers connected together by OSPF, and both of them lies under the same area, so no IPRs, no NIN, etc. A serial interface that is connecting R1 and R2 is running an encapsulation of triple P. So this is R1, this is R2, and the link between them is called the point-to-point or point-to-point protocol, triple P. Okay, so let's make it triple P. You see, just like old video, Cisco asks you about EIGRP, and EIGRP is removed from the CCNA. And this video, Cisco asks you about triple P, and triple P also is removed from the new CCNA. Maybe they are mentioned in the book. I haven't completed the book entirely, like in every page, but mostly triple P is mentioned in the book. Okay, so just for as an information for you, this says that by default, which OSPF network type in CCNP we will talk about network OSPF network types and configure them might be, and also in the CCNA I've talked about that whenever you have two routers connected together via a single link and using OSPF, this will be a point-to-point OSPF. If there was a switch, then you will enter this map, this long headache of that this might be a broadcast OSPF network, or if you used some frame relay protocols, it will be a non-broadcast, or it will be a point-to-point, multi-point with DMVPN, etc. But since there is a direct connectivity between two routers using OSPF, then it will definitely be called a point-to-point connection. So there is a point-to-point here, and that's it. This is how you end the question. Okay, so also by typing show IP OSPF interface, you will find some information in the CLI. In the first line you will see that the connection to OSPF is considered as a point-to-point type connection. So that's it. It's a point-to-point connection between two routers using OSPF. Okay, question 60. Which MAC address is recognized as VRRP virtual address? To memorize that, not certain, but let's see if the one of the guys here can help us. VRRP. There is only one thing about VRRP here, and it's in the topics. Okay, so it's in the next book. VRRP, GLBP. These are some informations for FHRP. Okay, these are the three flavors of FHRP. HSRP concepts, HSRP load balancing, which is something that is a manipulating for two groups together, not a default behavior. And let's see if there is a VRRP section here. FTP. Where are we heading? I think I have gone too far. Definitely. Go back a bit. Go back a bit. NMS. Okay, this is SNMP. Okay, this is where SNMP started. So let's see if there was any MAC address about VRRP here, because I can memorize part of it from the MCQs, but let's see if it's mentioned here officially or not. If it wasn't mentioned here, then using packet tracer will also be useful. We can configure VRRP on a packet tracer, but I will not because it's not mentioned in the CCNA exam. But we can do that just as an extra thing. Okay, let's go back a bit. The need for FHRP. So this is FHRP. This is where all starts. These are some things about FHRP. There is a quiz. There is a need for FHRP. Yeah, I think Cisco rely that you will do some hands-on labs with CCNA and then you should recognize the virtual MAC address of CCNA. Seems that it's not even mentioned in here. Okay, in the table, in the ARP, it will combine a VMAC. What is that VMAC? If you can tell me, if my eyes are not seeing that VMAC, it's not even mentioned in here as I can see. Router on a stick, and that's over. This is the starting of SNMP. Okay, then I will have to tell you that directly. You can use Google, of course, but I'll have to tell you that it's the one with the zeros and 5E. I can memorize it from the 5E and the 10A. I can memorize it from the 5E in the middle. So I will go with A, the 4 zeros, 5E 00010A. This is the virtual MAC address of VRRP. Of HSRP is different. So the system will create a virtual MAC, but the virtual IP you will assign it yourself to both the routers. Okay, for question 61. Oh, again, Atlanta, New York, and Washington. Is that the same one? No, this time the answers, I can see the answers are longer. Okay, refer to the exhibit. The New York router, which is this one, is configured with a static route. Okay, that is pointing to Atlanta and Washington sites. Okay, which two tasks must be performed so that serial 000 interface on the Atlanta and Washington can reach each other. Okay, so this serial 00 and serial 000, both of them need to reach each other using the IPv6 static route. What this means will be very simple. To do an IPv6 static route from New York to Atlanta using this destination, and I'm sorry, using this as a next hop, and the destination is its loopback, and this is for step 1. And for step 2, from Atlanta you need to configure an IPv6 static route with a destination of New York's loopback, and the next hop will be New York's serial 000. Okay, so I will need a route as a first step from New York to Atlanta that has the destination of loopback 1 of Atlanta, which is 2000 :1/128, and the next hop to reach Atlanta should be the serial 00 of Atlanta, which is this one, 2012 colon yes, yeah, the same IP address, colon 1. Okay, so this should be configured on New York. So let's see from these guys. It says that I think should be configured in New York. On New York, I'm sorry, from New York. Oh. Then how can I reach it? Okay, let's read the question again. If I missed that, then New York router is configured with static route. My bad. I'm sorry. Is already configured with a static route that is already pointing to Atlanta and Washington sites. So there is already a route heading from New York to Atlanta. There is already a static route heading from New York to Washington, but which two tasks must be confirmed so that serial 000 interfaces on the Atlanta and Washington, I don't know why my eyes thought that this is a New York, okay, can reach one another. I'm sorry. So the idea will be simply, why my phone is not silent today? I'm definitely sorry. The idea will be that New York knows how to reach Atlanta and Washington. The idea is now Washington and Atlanta, both of them, Washington and Atlanta, should reach each other, and that obviously can happen by going through New York. So I will need a first step of static route from Washington to New York and the second one from Atlanta, New York to Atlanta. Sorry, from Atlanta to New York, because there is nothing to be configured from New York. I'll need to configure Atlanta towards New York and Washington towards New York also. So I will need one command line from Washington, one command line from Atlanta, and these will be from Atlanta. I will need to configure to reach the destination of Washington through this one, the serial of the New York. So from Atlanta, I need to reach Washington. Washington loopback. Washington loopback is 2000 :::: 3 slash 128. And my next hop from Atlanta to reach Washington should be this one, this guy. So it's serial 000 of New York, which is my next hop should be 2012 :2 slash 126. Yes, New York serial 00. So we have three answers from Atlanta. One of them should be an IPv6 route to 2000. 1 minute. Okay, at least give me a next hop, a correct 2012. Okay, so this one refers to 2012. This one refers to 2012 : 2. But actually, yes, it's to : 2. So delete this one. And this one refers to serial 00. This one can also be used. So it's either D and E. But the next hop is not 2000 : 3. Actually, seems that the next hop is not the IP address of the loopback, it's the IP address of the physical interface, and this also works. Okay, this is what I did in my labs. Okay, then I will need to make the next hop, the destination is the IP address of this serial of Washington. So Washington's serial will be 2023 : 3 slash 126. Is there such thing? Yes, thank you. Thank you. This one. Okay. : Okay, and it's including everyone, even the three. Okay, good. Okay, to reach this network of Washington, go next to New York. Okay, so this one works. Okay, so from Atlanta to New York is solved. Now what I need from Washington towards New York, and from Washington what I need is that to reach the network of Atlanta, go to this interface, which is serial 001 of New York. 001 of New York is 2023 : 2 slash 126. This is the next hop, but the destination will be the IP address of Atlanta. The IP address of Atlanta should be, if it was its serial, then it will be 2012 : 1 slash 126. So one of these two guys should be this way. The first one 2001 : okay. Okay, so both of them matches here for the destination, but for the next one it's also 2023, but one of them is : 2, the other one is : 1. I will need the 2, so I will need this guy, so I will need B. Finally, took 3 years. Okay, so these are the configs from Washington and from Atlanta towards New York, and since New York is already configured, then network will be established after you apply these two commands. Hopefully this was useful for you. Okay, let's head and jump for question 62. Question 62, says a router that's running EIGRP has learned the same route from two different paths. Whenever a router elects a specific route, then this route to elect a specific path, it will use its own metric. Okay, and in RIP it will be the shortest path. In OSPF will be the path with the best bandwidth, the highest bandwidth, or the lowest cost. In EIGRP it will be multiplying a very complicated and big it's called the formula that contains all the 5 key values of EIGRP to give you one very big number to choose which one, 2 of them should be used, and this one is called the metric, the EIGRP metric. Okay, so it's metric of the EIGRP metric, so it's classic name. Okay, so which parameter does the router use to select the best path? If it was the EIGRP, it will use a metric. If it was an OSPF, it will use cost. If it was static route, it's static something. If it was a rep, it will use the shortest hop. So AS path, I know this one is for BGP, and this is complicated for you so far. Administrative distance is for before even electing a protocol. Metric or cost, this one is just for SPF. This one is for EIGRP, so it will definitely be EIGRP. And you can use this one as a generic concept of electing between two paths, because all of the other guys, metrics is also called metric, but OSPF has a specific name of cost. Okay. 63 says an engineer configured an OSPF. An engineer configured an OSPF neighbor as a designated router. So I'm here and I have configured this guy as a DR. Which state verifies that the designated router is in the proper mode? Initiate two-way exchange on full. Whenever there is a DR in the network, then this DR will be a friendly guy that will perform a fully adjacency relationship with every other router in the network, all the other guys. So since it's a DR, then it will definitely be a full adjacency between me and him. So it will be full D. Question 64 will be, refer to the exhibit, which route does R1 select for traffic that is destined to 192.168.16.2. So 192.168.16, all the guys right here matches, but what we need is the longest match. Okay, so the longest match is better. So the smaller subnet mask is better. This is a very big subnet mask. Actually, this is a very big network, a smaller number, but it's a very big network. This is smaller, and even smaller. But this one is using LI. Oh, this is ISIS. Which one is preferred most? Which one is preferred most? The longest match or the protocol? I think no, the longest match is preferred most. So yes, so we need to look at the smaller network, which has the biggest subnet mask. So since all of them from the perspective of IP address include, then we need to look for a smaller subnet mask, which is 27. So this one will win, which is an I. It's an ISIS. If all of them had the same subnet mask, then we will need to choose the one with the smaller AD, administrative distance, which is here actually the EIGRP. So this will be option 1, option 2 OSPF, option 3 ISIS, option 4 the RIP, the RIP. Okay, you can see that it's a D because it has held an old name from Dijkstra algorithm. That's why it's D, not an EIGRP. But anyway, right now we have all of them are different in subnet masks, so we will look at which one has the longest match term, which is the I. So this will go through 192.168.14, or actually this network, which is /27. Then I will go with /27. Okay, so it will be answer D for question 64. For question 65, working shown this way. Okay, refer to the exhibit. This is the exhibit. If configuring a static default route on the router with this command, this is a default route command, I agree, and this is a destination. This is a floating static default route. How does the router respond? Okay, it's using 120 as an AD, as a floating. 120 is the AD of RIP. So you will need, what do we have here? We have C and L, and there is an O. There is an OSPF. So as long as there is an OSPF, OSPF will be used. And once the OSPF fails, once gigabit Ethernet 00 fails, only then a route with an AD of 120, which is higher than 110, will be considered functional. So as long as this interface is up, then this one is neglected and hidden, and it's not even installed in the route. You can see that there is no such thing in the route that has an AD of 120, but you need to disable this interface or make this link goes down or fail. so that this one will be deleted from the route and this one will be replaced with. So it starts sending traffic without a specific matching entry in the routing table to gigabit 001. It immediately replaces the existing OSPF route in the routing table with the newly configured. No, it's not immediate because it has a higher AD. It starts a load balancing. No, it ignores the new static route until the existing OSPF default route is removed. Yes, it will be D, because as long as there is an OSPF, this one will work. But once this OSPF with the ID of 110 goes down, then this one with a higher ID will be installed and shown here instead of the OSPF and will work. Okay, so it's either by removing the OSPF or disabling the gigabit Ethernet 00 interface, or okay, that's it. Okay, so this will be answer D. Okay, question number 66. Which two actions are performed by the weighted random early detection, RED, WRED? This is a quality of service mechanism that should only be mentioned in the CCNP exam. Let's see if I can memorize some of them. Which two actions are performed by the randomly? This is a mechanism that what it does is actually that when you have like the quality of service, I've talked about policing, shaping, etc., and marking, queuing, and so on. Like you have an interface that has an ability of 100 megabit per second bandwidth, which is fast Ethernet interface. And what will happen is you use some marking and queuing and also some classification mechanisms and criteria for quality of service to make the very high or very important traffic category has a 50% of the interface bandwidth. The high has 20, the medium and low has the rest 30, like 15 15 or 18 12, and so on. By enabling RED, WRED, the random, what will happen is that whenever one of these queues gets filled, like the very high queue, it's not even restrict or such thing, but it has a WRED enabled, or maybe the high one, the high queue. Whenever the high queue gets filled and its capacity is only like 30% of the entire link, so it's 30 megabit of the link, so it's receiving like 35 megabit per second. What it will do is that it will start to drop randomly. It will start to randomly drop some packets of those excess 5 megabit packets. So it will start randomly to drop a packet that has a value of 5 megabits per second, so that it will leave only 30 megabits per second to flow through this link at a certain moment. So this is what our WRED does, and we will definitely talk about that in the CCNP, but not here. Discuss questions anyway. So it supports protocol discovery. No. It guarantees the delivery of high priority. It's not guaranteed. It will start to randomly drops. So you cannot guarantee what will be dropped. Actually, it can identify different flows with a high level of granularity. No, it's not your job, but let's see if there is another possibility. It can mitigate congestion. It does mitigate congestion because it's a QoS by preventing the queue from filling up. Yes, and how is that happened? By randomly dropping some packets so that the queue will not get filled. Okay, and packet loss will not happen. But you are having a packet loss because it's dropping packets. It drops a lower priority packets before it drops a higher priority packets. Actually, it does that randomly. Randomly which packet, not which packet priority. That's what makes sense, because C does not. So I will go with E. This one makes sense, this one does not. One is definite correct. Okay, so let's go with E. Because it will drop packets randomly. I don't know what's inside of that packet, and since it's a TCP packet, then it will retransmit again a few microseconds later. But will these packets be a lower priority than a higher priority? Maybe. I think so. I think we'll have even more interpreting and discussion regarding this in the CCNP in-core exam. Okay, so but for the time being, D and E seems correct and enough. Okay, let's head to question 67. Refer to the exhibit. An engineer, I will correct that before uploading. Why did that happen? Okay, an engineer configured NAT translations. Okay, and has verified that the config is correct. Okay, which IP address is the source? Source should be inside local. Show on this one. Okay, but we have two different. Configured NAT translation has verified the config is correct. Which IP address is the source IP? Source of what? I have inside local and inside global. Inside local is the private IP address that is used in the company. Inside global is the public IP address that my company has bought for itself. So what do we have here? Which IP address is the source IP? Those guys are a destination. So it's one of 4 IP address and 3 of them are already listed. So question 67 says it's not Pat. I can tell because there is no one unique IP address that has been used globally. This is strange. Okay, 1 minute. This guy is 172.23.103.10. This is not even mentioned in here. Oh, this is a destination. Okay, so it's not this one. I believe it means the source of the information that I am receiving from the internet, which is the public IP address on the right. 1 minute. It means the source of the IP address of the information that I'm receiving, like from website.com. So it will be the public IP address of that website or that company. It will be the destination, the outside. Okay, and you can see that since only one IP address, so it will not really cause some conflict. It should not make me confused actually. Yeah, I was about to just delete that and block it, but it's this one, I'm sure. Talking about the source of the IP address that is sending me information from the internet. It will be this guy. Okay. And actually, the unique thing that this is a private IP address, 172.23. What is the source of the information that's coming to me? Okay, question 68. If a notice level message in syslog, notice means N, notification, is sent to a syslog server. Yeah, okay, should be reported to the server. Which event has occurred? Okay, it depends. A network device has restarted. This is an emergency, not a notice. A debug operation, a debug is a debug level. Okay. A routing instance has flapped. I'm not sure. An ARP inspection has failed. If an ARP inspection has failed, I think it was like number 5 or 3 or 5. What was then? Debug formation notification of this error. Something higher for ARP fail. For C, the routing has flapped. Word flap means that something was on and working, suddenly became off and immediately became on again. Software or even hardware reasons, mostly it will be hardware reasons, but this is what the word flap means, like something you can monitor it through some monitoring portals that was always going this way and working normally, suddenly did this and resumed working normally. So I think this is something to notice, that you should, this is not an emergency because it did not went down completely, not a critical, no. So I will go with C because it's only a flap, and flap sometimes happens only for one time and never come happen. I'm sorry, never happens again. So that's why we can consider it as a notification or a notice message. It should be good for the 68. Question 69, the D and D. Drag and drop the functions from the left to the correct component on the right. I have two types of servers, three blanks, five, so I have to use all of them, the five of them. What I have is actually, okay, we have crossed an hour. Okay, that's it. We will finish at question 76. Good. DHCP server resolves web URLs to IP address. Definitely, if you have studied chapter 4 with me, then you know DNS does that. Assigns a default gateway to a client. This guy does assign IP, subnet mask, and gateway. Holds the TCP IP settings to be distributed to the client. TCP IP settings to be distributed to the client. 1 minute. This is a manipulation. 1 minute. Stores a list of IP addresses that are mapped to names. This guy. This guy. That's your job. It's your only job. Assigns IP addresses to enabled clients. As I said, the DHCP server assigns IP subnet gateway to guys, and it seems that this one must fill or fit here. Holds the TCP IP settings to be distributed to the clients. Okay, so it will be this one. Should be good. Question 70. Which two tasks must be performed to configure NTP to a trusted server in client mode on a single network device? Which two tasks must be performed, okay, to configure NTP to a trusted server in client mode? Oh, I'm sorry, you mean that I have a router that I should configure it as a client, NTP client, and I should configure that you will be a client to this trusted server. I guess so. So let's see. An NTP, enable NTP authentication. It's trusted, so why would we need authentication? Verify the time zone. I will take the time zone from the server. Specify the IP address of the server. Definitely, this is how I can reach it. Set the NTP server private key. If it was trusted, then okay. Mostly disable NTP broadcasts. Disable NTP broadcasts. New. I will go with the, because there should be some encryption between us. Okay, especially if it was SNMP-v3, then there will be some encryption between them, and there is a private key between them. Okay, so it will be C and D. C definitely no discussion, and D also for encryption. Okay, this is for question 70. Almost done with this video. Another D&D. Drag and drop network protocols from the left into the correct transport service on the right. Connection oriented, those are TCP guys. Connectionless, those are user datagram protocol guys, UDP. Okay, these are some protocols. Good thing that all of them are already mentioned in the course. Good. FTP has TCP 20 at 21, so it will go here. SMTP has TCP 25, so it will go here. SNMP has UDP 161 and 162, so it will go here. SSH is TCP definitely, so it will go here. As here, SSH was TCP 22. TFTP, trivial FTP is UDP, is unreliable, is UDP 69. VoIP is voice and video are UDP for fast retransmission. So VoIP will definitely be a UDP application, just like we have talked in the quality of service video. This was was simple. Okay, so it should take a maximum of you in as in 1 minute in the exam. Jump, you have a time count. Okay, but don't get confused and hate me because I said that. Okay, question 72 says that hour and 10. What time is it? Anyway, no matters. We will finish in 4 questions. I'm sorry. A network engineer must back up 20 network router config globally within a customer environment. Mm. Which protocol allows the engineer to perform this function using the Cisco ISMIB? In an ISP and customer networks, what you will need to do every 30, 60, or even 24 hours, every 30 minutes, 60 minutes, 1 hour, half an hour, 1 hour, or even every 24 hours, I mean once a day, you need to have one of the servers that do communicate with all the routers and switches in the network, and do ask them repeatedly, like every interval, every like 1 day, every 24 hours, to send him, this guy, send it to this guy, this server, to me, to send me all of your current running config, just in case one of you had a disaster, performed a reload, enter the roaming mode where you have lost the config, had hardware failure. In all of the cases, what I will do immediately is that I will send a technician or a support engineer to the site. He will install immediately a spare part, a spare device, just like the corrupted device. And with the USB flash stick, it will inject the USB flash stick to this new spare device, enter this backup or recovery or disaster server, take a copy of the latest and the newest running config, and paste it to this device, so that in a matter of like 10 to 15 minutes, this device will operate just like the old corrupted one, and you can migrate all the cables from the old to the new device, and that's it. You are back to the network, no outage. We are done. We are settled. Later on, you will have to figure out what's wrong with the old one. So this is something very important. You have to do that for your customers and for your network. You will never guarantee a behavior of any device at any moment and for any reason. So which protocol to do that? It says ARP. ARP has nothing to do that and cannot be reinstalled on some servers. CDP definitely is not the guy to do that. SNMP servers do that. They do have some GET requests and they can do that. SMTP, problem is I have never deeply studied SMTP, but I'm sure that SNMP does that, and I faced such scenarios before. SNMP servers, syslog servers, other servers do get they have this ability to retrieve and store a copy of the config of devices and store it inside them, so that you can enter this server, take a copy of the config, and immediately send it to the backup device. So you can go with SNMP. That should be good for now. For question 72. For question 73, let's pick up a pen. Which command enables a router to become a DHCP client? Yeah, a router can be DHCP server to give IP addresses from the pool, but just in case, this guy here is a DHCP server, SRV, and it has a cable that connects him to this router, and you even want to make this router gets an IP from the server, not to assign it statically, because you have no idea what IP addresses that you can use without duplication. Then you can enter this interface and says IP address. Before we had to type the IP address and subnet mask. Now we will type IP address DHCP. Leave it for a matter of seconds, or maybe even 2 to 3 seconds, and refresh the show IP interface brief command table, and you will see an IP address with a subnet mask definitely assigned to this interface from this server. And this happens a lot in the networks. Okay, so IP address DHCP, this guy, this is the first one, this one does, and the function, the job, and that's it. That should be enough. Okay, for question 73. For question 74, refer to the exhibit. This is the exhibit. What is the effect of the config? IP ARP inspection, good. For VLANs 5 to 10, so all of them are untrusted. Interface fast Ethernet 01, switchport node, switchport mode access, okay. Switchport access for VLAN 5, but you did not make it as trusted, so you have killed everything. ARP inspection is just like the port security. Whenever you enable it for some VLANs, then all of those VLANs by default gets untrusted, and you'll have to retrust some specific interfaces again. I've talked about that in chapter 5. I believe it was even not the last video, before the last video for the ARP inspection. Okay, so the option says the switch discards all the ingress ARP traffic with invalid MAC to IP. Not about valid or invalid, it will be disaster. Okay, all ARP packets are dropped by the switch. I think egress traffic is passed only if the destination is a DSC server. No, it's not about that. It's not about that. All ingress and egress traffic is dropped because the interfaces is untrusted. No, not all the types of the traffic that will be discarded. C and D definitely are incorrect. ARP packets are dropped by the switch. Actually, for the ARP switches, it should be all the ARP switches trying to ingress interfaces lies within VLAN 5 to 10. So if there was some interface that lies inside VLAN 1 or VLAN 2, 3, 4, then it will not be discarded or dropped. This is annoying. Okay, I don't want to make this video like 2 hours. Let's finish it. We have only 2 questions left. So C and D is definitely incorrect. A says switch discards all ingress ARP traffic that have an invalid MAC to IP address bindings. I'm not sure, because B seems more correct. I will go with B. B seems more correct, because it's about binding already. So I will go with B for me. I assume that the device has only these 5 VLANs configured from 5 to 10, and that should be enough. So I will go with B for me. On B. Okay, so let's pick the pen again. 5 and so. When a side-to-side VPN is used, I have talked about side-to-side VPN. Yeah, let's hope this question is from that. Which protocol is responsible for transport of user data? IPsec, IKE version 1, MD5, IKE version 2. This is the hashing algorithm. IKE v1 and IKE v2, I'm still weak with these because I'm still studying them. I did study them, the CCNP before, but not that specific because they were not mentioned really. The others, not much. Which protocol? Okay, as a protocol, I will go with IPsec. IPsec is actually a secured IP address. Whenever you enable side-to-side VPN, you will have to use the secured IP address, not the normal old IP address, which you can inspect it and see what's inside the header and the payload. So you'll use IPsec, and I believe IPsec will encrypt or hash all the data in the header of the IPv4, not in the payload. To hash one of them. So IPsec will be used with side-to-side VPN for transport. In the CCNP Encore exam, we will have to do a lot of videos regarding these 4 guys. I have read them in the CCNP advice. Okay, so let's go with IPsec for now. And one last question, and enough for today. Which type of wireless encryption is used for WPA2 in the pre-shared key mode? WPA1 derived it from the passphrase. WPA2 also derived it from the passphrase, but in WPA2 there was a new algorithm. Why did I forget about them? Why did I forget about them? Wi-Fi security. Wi-Fi security. WPA2 used 256 and RC4 plus TKIP. WPA1, I'm sorry, WPA2 used the AES with CCNP instead of the RC4 plus TKIP, but RC4 and TKIP kept supported. But this is the new one, the AES plus the AES, I'm sorry, CCNP. So just run backward. This says There is an AES, there is a TKIP, there is an RC4. RC4 will not work alone. RC4 needs TKIP together to work, and there is two AES. It will not be 128, it will be 256, and WPA3 will use the 192 with another bit with another protocol. So I will go with C. This is for WPA1. This will not work alone, and since WPA1 is already based on 1256, okay, so leave this one also. I will go with C. Yep, that should be okay. Okay, so that should be enough for today. I will even write these down here. That should be enough for now. These are 26 questions. Actually, I have typed 26 questions instead of 25 in this PDF slide. So I hope all of these were useful. Just in case you have any question or something, you can comment down below in the video. And soon I will start to record the fourth video. The fourth video will be the last for April. In May, June, July, etc. Whenever there is a new things that you need to know or that might be useful for you, I will record them and publish them. So thanks a lot for watching so far. Hasn't been like really short time, but I hope that it was really useful, and I would like also to see you in the upcoming video. Goodbye.